acting on the boom which supports a sign. So a sign, which has a mass of 28 kilograms, is suspended from the end of a uniform beam, called a boom. It has a mass of 25 kilograms and a length of 2.2 meters. The beam is kept horizontal by a hinge and a cable which is set at a 30-degree angle with respect to the boom. Two questions: what is the tension Ft in the cable? And B, what is the force on the hinge? Force on the hinge, let's call that Fh. Okay, so to begin the problem, what I'm going to do is I'm going to label all the forces that act on the boom. So let's begin by marking the center of gravity of the boom. It's a uniform beam, so it would be dead center, located 1.1 meters from the edge. So we'll call that mBg, be the weight of the beam. And we also have the force of the sign, or the weight of the sign. And what I'm going to do is I'm just going to draw that over here. So that'll be, let's call that MSG. Now the cable acts on an angle. The angle is 30 degrees acting in there. And there are two forces that cable provides. It provides an upward force. Let's call that Ft in the y direction. And there's also a horizontal component to it, which is Ft in the x direction. Now, there's also the hinge. The hinge provides a force, basically a normal force acting on the boom. So we'll call that Fhx. And the interesting thing is that we don't really know if this hinge is acting, the force in the y direction of the hinge. We don't know if it's acting upward or downward. So I'm going to take a guess that it's acting upward. When we calculate Fhy, if it turns out to be a positive number, then we know that we guessed correctly. If it calculates to be a negative number, then we know that we've guessed incorrectly, so we switch the signs. So we're going to have to take a guess to proceed with the problem. So those are all the forces that act on the system. Let me also add the length just to clarify. So that would be the length of the boom right there. So our diagram is now complete, and we can now proceed to do our calculations. So what I'm going to do is I'm going to start off with the first condition of equilibrium, sum of the forces. And since we have forces in the y direction and the x direction, I'm going to have to apply the first condition of equilibrium twice, once in the x and once in the y. So the sum of the forces in the y direction we know is equal to 0 because this is in static equilibrium. And we have Fhy, force of the hinge. Now we've said that that's positive. And we have the force of the tension of the cable. We know that is in the upward direction, no question there. We know that the weight of the boom is downward, and we know that the weight of the sign is downward also. So those are all the forces acting in the y direction. Now we could further expand this. We know that Fty, so let's expand that. Fty is going to be Ft sine of the angle, theta, minus mBg minus mSg is equal to 0. So that's our first statement. Just put a box around that, just to show that that's one part of the problem. Now we're going to analyze the forces in the x direction. So that would be some of the forces in the x direction are also equal to 0, and we will have FHX minus FT in the x direction, and that's equal to 0. So those two forces cancel each other out. And we know that the force of the tension in the x direction is going to be equal to the tension times the cosine of the angle is equal to 0. So let's put that in a box to isolate it. Now we can apply the second condition of equilibrium. So that states that the sum of the torques is equal to 0. So what I'm going to do is I need to decide where to put the pivot point, and I'm going to decide to put it at the hinge. And the reason for it is that I don't know anything about the hinge. I do know some things about the opposite end of the boom. I know the weight of the sign, of the fun sign. The weight of the sign is equal to MSG. I can calculate that. And if you look at the free body diagram, you could tell that FTY, if you look at, sorry, not there. If you look at the sum of the forces in the y direction, I can calculate FTY. I know this, I know that. I do have two unknowns there, but I've already started solving the problem in the y direction. So I'm going to set the pivot at the hinge. I don't know anything about the hinge. Okay, and so what that means is let's mark that on our, so we have a pivot point right there, P, and let's start doing some of the torques. So I have some of the torques. That would be FHY times 0. So there's no torque provided by the hinge. So that's 0. And the next force would be MBG. So that would provide a negative torque. So MBG times L over 2. And then the next force that I have would be the sine, and that would provide a negative torque also, MSG times L. And then the last force provides a clockwise torque, so that would be FT sine theta times L, and that's equal to 0. So that would be my statement for the torques, and I have two unknowns. I have three equations. I can combine them, and I will leave that up to you to combine them. And in the end, we have FT is equal to 793 newtons, and FH is equal to 698 newtons. And that's it.